Okay, so one last video I wanted to make in this section, and wanted to start in the textbooks. We haven't really talked much about the textbook, so just share my screen here. So I've got the textbook open to 10.2, and one of the nice things about, well, first of all, this is free, so that's really nice. The previous video I went through had a derivation like this. I did a little bit different in terms of what my letters were. In terms of using a textbook, it's like, this is an important resource for you to think about, getting both instruction and getting practice and validation. So I want to jump into an example problem, example 3 here. And, one of the things that I like about this online textbook is the show hide solution. Some of the examples have the show hide solutions. And I think that's a nice way to kind of test your understanding of things. That's what we're going to do here. I'm going to copy this and I'm going to bring it over to a whiteboard. We'll talk a little bit more about some of the other features in the homework. Okay, so lots of words, and of course, the starting point has to be you kind of processing everything. And so I'm going to just start with some basic things. There's 2 towers. So I'll make a little cell phone tower, another cell phone tower, and they're 6,000 feet apart. And the signal is 5,050 feet from the first tower and 24,200 feet from the second tower. So there's our triangle, because our signal is here, right? And we can see the distance here, we can see the distance here. So basically I have a triangle. So now I don't need my towers anymore. I'm just gonna put the sides in. So this is a law of cosines problem, because I'm asked to determine the position of the cell tower north and east of the first tower. So like, I'm imagining if this is north, and they did tell us here this was east to west. So this is going to be north and this is east. So basically I want to find those 2 dimensions, like I'm thinking about this as a 0, 0, rectangular coordinate plane. So how much is the y, how much is the x? So to do that, I really need to know something about this angle here. And so that's setting me up now to use the law of cosines, because with 3 sides and a missing angle, I can set up my law of cosines. Remember the law of cosines, c squared equals a squared plus b squared minus 2ab cosine theta. I can orient this any way I want, but the key is that this theta is across from this c. A and B are the ones that are adjacent to the angle. So I'm going to set this up. 50/50 squared plus 6,000 squared minus 2 times 50/50 times 6,000 times cosine theta equals 2420 squared. All right. So a lot of times I see students having problems with the order of operations here. Just be clear that you can certainly put together the a squared plus b squared part, but this part is multiplying cosine theta, so it's going to become the coefficient of cosine theta. I can't deliver it. 50/50 squared plus 6,000 squared is going to be a big number. 61502,500 minus 2 times 50/50 times 6,000. That's a big number. Looks like 5 zeros. And that's multiplied by cosine theta. And this whole thing is equal to 2420 squared, which also a big number, 5856400. Okay, so now I just need to do the algebra. The algebra here is, I'm going to get rid of these big numbers and just give you an example. 2 equals 3 minus 4x, right? I need to solve for the missing variable. I'm going to get this number over, and then I'm going to divide by the coefficient. So step 1, let's subtract 58. Let's see, was that 5 million something? Now this is going to end up negative. Shouldn't be surprised by that. Minus 55646,100. Right, because this is 5 million and I was subtracting 61 million, so I end up with 55 million. Okay, so this all makes sense. All right, and then minus 60 million times cosine theta. So now I'm dividing. Got a negative divided by a negative, so I got 0.918 equals cosine theta. So theta equals, so here's my time to use inverse cosine. Okay, it looks like 156 degrees. Something doesn't feel good about that. Make sure I got my negatives right here. 55,646,100, 0.600,000. Our cosine of that. Inverse cosine. Oh, okay, 23.3 degrees. So first of all, the first number I got was like over 100 degrees. It was a bad sign because this side is the smallest side. It should be the smallest angle, right? If I'm already over 90 degrees, I got big problems. Now, I'm going to go back to thinking about how we can figure out the north and the east question. How far it is from the highway, I assume is just going to be the north value here because it's the sort of perpendicular distance from the highway up to that cell phone tower. So basically, I know that this triangle, do some redrawing here. Oh, okay, lost all of the words, that's fine. 23.3 degrees. I know this is 23.3 degrees. I know this is 50-50. I don't know this north and I don't know this east part. If this is 23.3, then I can work out that this one is 90 minus 23.3. Also, this angle must be 23.3 degrees. That's another way to do it. Why is this 90 minus 23.3? Because if the north line is perpendicular to the east-west highway, then that has to be 90 degrees. So I'm just taking that off. So I'm looking at 66.7 degrees, and now I'm ready to use some SOHCAHTOA. So I've got, notice that I'm not afraid to just keep redrawing this to kind of reorient myself. Sine of 66.7 degrees equals the east measurement over the 50-50. And then the cosine of 66.7 is going to be the north component over 50-50. So now I can just do the math to calculate both of those parts. So I'm looking at the east part is 4638.2, and the north part is When I use my calculator, I have to be careful because some buttons don't register when I push them. So I'm watching my screen and what I'm supposed to be typing, kind of double checking as I go. Okay, so there's that. And then I would answer that the north part is how far the cell phone is from the highway. All right, so let's see how we did. So we go over here and click on show hide solution. Okay, so it's a pretty good drawing of what we had. Key, the 2420 is alone there. They do some operation. They move the 5,050 squared and the 6,000 squared over here, end up with the 23.3 degrees. So that's nice. And then the 23.3 degrees, they're actually using this triangle instead of redrawing the one that was above it. Shouldn't make any difference. We get the north part as 1997.5, which is what we got, and 4638.15, which is also what we got. And the 1998 is the feet from the highway. Now, as you get into problems, you're doing the homework, notice that all of the odd numbers have links at the bottom. So if you do this problem, you can then link it to the bottom and it will jump to the solutions. You got to kind of wait a second. We're at 10.1 and it eventually loads up. There's some JavaScript or something working in the background, but it took a while. Now, all that you got here is the answer. Very important that in the bundle, you understand that writing down the answer is not good enough to get credit for having done that, right? So to prevent you from just going to the back and writing down the answers to the problem. I try to mix between even and odd problems. If you find an even problem and you want to feel like you've checked your work, then what you should do is do an odd problem next to it and make sure that you can do that and get positive feedback. Yeah, so it's not perfect in terms of going back and forth from the problems to the solutions. And as I said, you got to wait a second for it to kind of catch up because it'll do that and then it'll scan down. But, you know, the checking the solutions, I think, is an important part of making sure that you feel like you're on the right track. If you have problems that you're confused about, you can wait till Saturday to talk about it, or you can send me a text and say, you know, take a look at this problem. I got this answer, but I'm not sure, or I got a different answer from the back of the book. And we can do some work by texting. You know, you send me a picture, I'll send you some feedback, or I'll make a video for you, or I'll suggest we meet up. That's really important that you know that there's an interactive component to the support that you can get in the class. All right, I'll talk to you guys later.